Hello! This will be a demonstration of Proposition 21 from Book 9 of Euclid's Elements, which says that the sum of even numbers is also even. We're given four numbers, AB, BC, CD, and DE, all of which will be even numbers. And what we want to prove is that their sum, which is the number AE, is also an even number. For since our four given numbers, A, B, B, C, C, D, and D, E are even numbers, we were given that information. Each of them naturally has a half part, just by definition of being even numbers. That's definition 7(6). It's because each of the four numbers, A, B, B, C, C, D, and D, E, each has a half part. Their sum, which is the number AE, will naturally have a half part as well. But since the number AE has a half part, it is therefore an even number. Again, just by definition of even numbers, which is definition 7(6). An even number is any number which has a half part, or which is divisible by 2, or divisible into 2 equal parts. So since AE has a half part, it of course follows that it is an even number, which is what we set out to prove, which means we're done with the proposition, therefore, etc., QED. This is the first of many propositions to come about even and odd numbers. There will be a lot of propositions in the future that are about how these numbers, even numbers, add to each other, how odd numbers add to each other, how even and odd numbers add to each other, how they multiply by each other. So this sort of proof is going to be it for a little while. Makes it nice for me because they're all very short, so hopefully they're also easy to follow. I do want to give an example before I close out the video. So say we have four even numbers, 4, 6, 8, and 10. I'm sure you can agree that all of those are even numbers. And what we want to prove is that their sum, which is the number 28, is also an even number, that 28 has a half part. How Euclid goes about proving this is it begins by noting that each of these numbers, 4, 6, 8, and 10, by definition of being even numbers, has a half part, right? So 4 has the half part of 2, 6 has the half part of 3, 8 has the half part of 4, and 10 has the half part of 5. So if we add all of these together, the sum will have 2 2s, 2 3s, 2 4s, and 2 5s, which means it's going to have a half part exactly equal to 2 plus 3 plus 4 plus 5, because there are 2 of each in it. So 28 is going to have the half part of 2 plus 3 plus 4 plus 5, which is 14. And because 28 has the half part of 14, it of course follows that it is an even number, because an even number is any number which has a half part. So having shown that 28 in this case has the half part of 14, we have successfully proven that it is in fact an even number, so we see that this proposition here holds. That's all I've got to say about this one, so I'll end the video here and move on to Proposition 9.22.